Okay, so there's a couple other equations that you can use. They aren't really necessary because you should be able to find these values based on the PV equals nRT equation. Kind of like on your worksheet, it asks for density. All you'd have to do is you'd find your N moles, change that to grams, and then divide by the volume. But you can use a specific equation just to find density if you want to, but you don't have to. So since if we're going to find the molar or the number of moles of something, you take the mass divided by the molar mass, because let me see if we're given a mass of a substance and you want to find the number of moles, don't you have mass here? You have the molar mass on bottom and moles on top, grams per mole, but grams will be on bottom, right? Write it up there if my pen worked. There we go. So if we're given a mass, so in grams, right here, we'd have to, if this was given to us, whatever that was, we'd have to have grams here and moles here. And this would be the mass from the periodic table. And so we call this big M for molar mass, and moles, G, mass here. So if we're trying to find N, the number of moles, we take the mass divided by the molar mass, correct? So if we have our equation PV equals nRT, and I want to sub in mass divided by molar mass is equal to N, I can put PV is equal to mRT over molar mass, because now N is mass divided by molar mass. So that's what this equation is saying. And then you can rearrange that for molar mass. So I'd multiply by molar mass here on this side to get that on this side, and then divide by PV, so we'd have mRT over PV. Really? Okay. So that's what this equation is, if you're just looking for molar mass. Now, you don't have to use that, because to find molar mass, it's just grams divided by moles. So if you found N for moles, you take the mass of that sample divided by moles, and you could find your molar mass. Okay, and then density is M over V. So if you look here in this equation, we have mass over volume right there. So all they do here is substitute D, density, in for that. So we have M is equal to dRT over P. And if I rearrange this equation so that D equals something, D is equal to PM over RT. Oh my goodness. Which is this equation right here. Yes, I will give you all the equations for the quiz and test. Okay. But you don't have to use those equations if you don't want to. You can still use just the ideal gas law, and then just remember density is mass divided by volume, and molar mass is grams divided by moles. So do we have a problem? So at 28 degrees Celsius and 0.974 atm, 1 liter of gas has a mass of 5.16 grams. What's the molar mass of this gas? So what we could do is use our PV equals nRT equation. Here's our pressure, volume. We'd solve for N. We know R. And here's our temperature. So once we solve for N, We could take our 5.16 divided by whatever we got for N, or you can use your molar mass equation. So you can do it either way. You don't have to use the equation. You can, if you know the one equation, you should be able to solve all of these. So what do you want to do? How do you want to solve it? Use the molar mass equation or the ideal gas law? How about we do it both ways for this one, and to show you how you can do it both ways, and then we'll decide for the next one. So let's use the PV equals nRT equation first. So our pressure is 0.97874 ATM. Make this a little thicker. Volume is 1 liter. Remember, R you have to have it in ATM, liters, and Kelvin as our units. We do not know N. That's what we're going to try to solve for. R is always 0.0821. That's a 2. And then our temperature, (301). Right, we have to have it in Kelvin, so add 273 to that. So then we'd solve for N. What do you get? What? 0.039. Seems small. Does anyone else get that? Okay.
Need to have the 7th graders dismissed from class at this time for their testing. If your last name begins A through K, please report to room 402. If your last name is L through Z, please report to the cafeteria. That 7th graders need to be dismissed.
7th graders have testing?
Also, these students need to be dismissed from class at this time for makeup tests. They do need to report to the cafeteria for those. Those students are Chance Vorderstrass, Brody Vorderstrass, Latifa Root, Mark Brown, Matt Brown, Jesse Ackerman, Levi Cermak, Brianna Shook, Zach Sloan, Miranda Harpham, Kaya Harpham, Jacob Zolkowski, Brooke Zexer, and Chantel Stewick. Please report to the cafeteria for your makeup test.
Wow. And the units for molar mass, since we're finding molar mass, is grams per mole. So we're going to take, we want it in grams per mole. So we are going to take the mass that we have, 5.16 grams, and that is 0.039 moles. So now our units are going to be grams per mole, which is what we want. So our molar mass is what is it? 0.23. So 132.2 or 132.3 grams per mole. 132.3 grams per mole. So that's how you can use the ideal gas law to find it. Now let's use the other equation and see if we get the same answer. The equation for molar mass was MRT over PV. So our mass in this case is that 5.16. R is 0.0821. Our temperature we know is 301. Pressure was 0.974. And volume was 1. So let's see what we get there. We should get about the same. Might be a little different just because of rounding differences, but 130.9. And that really can be because this number is rounded right here, the 0.039, so you can get a little different. So you can do that problem either way, and it'd be okay. That next problem is exactly the same, looking for the molar mass. Gives you grams, gives you pressure, volume. What would you have to do with the volume? Right, you need it in liters. So how many liters would that be? Divide by 1,000, and it's 0.125 liters. How would you want to solve it? Do you want to do it the top way or the bottom? Bottom. Okay, so let's rewrite that. 0.125 liters. So our molar mass was equal to M. What's M? What is it? Right, 427, the mass of the gas that we have. So R, it's MRT, R is 0.0821. What's our temperature? And it's over pressure times volume. What's the pressure? Volume, 0.125. We had to change that to liters. 82.85. $83.85. Okay, the next one is talking about density. So when you do a density problem, really you can use the PV equals nRT equation. You find moles. You'd have to convert that into grams and then divide by the volume, or we can use our density equation. So let's just do the density equation. Oh. I don't know. Is that what? No one else got 83? I get 83.85. Right. Do you have it punched in that I could look at what you have typed in?
Chuck here.
Okay, so it's dividing by 0.98 and then taking that and multiplying all of that times 0.125. So you want to put another divide there or put parentheses around the bottom. Okay, so the density equation is D is equal to PM over RT, or MP over RT. The big M is the molar mass, so you need to know what gas you're dealing with. So what's our pressure? 0.98. M would be 17.04. That's just from the periodic table. We're dealing with ammonia, NH3, so find its molar mass. Add it up on the periodic table. R is 0.0821. And then temperature, .336. .661. And so our units for this is grams per liter. Questions on that one? I don't know. I'm just...
It's all right.
I'm putting in 17.04 times 0.980 equals 16.6. And I press the divide button.
Put the parentheses.
Why do you put parentheses?
Take her down, Nate.
If you put 0.0821 times 336, you have to use parentheses, because otherwise it's going to divide by R and then multiply that whole thing by 336. Or you could put divide by 0.0821, divide by 336. Just make sure you use divide both times, because you're dividing the top by them both. But yeah, it should be 0.61.
Well, I don't know what you guys are saying, but I'm
So close, Nate.
You're still getting that?
Look what I'm doing. You're telling me
Okay.
to put in parentheses. So I do that.
Okay.
Press equals.
Yes.
I press divide. So I put in parentheses. 0.0821 parentheses.
No.
Times.
No parentheses there. Don't put the parentheses there. Now put, no, wait, 0.0821. Now times 336. Now parentheses. There you go.
How you gonna stay?
What do we got here?
What's like the units for that?
Grams per liter. So this one, the density of a gas was found to be 2 grams per liter at 1.5 atm and 27 degrees Celsius. What's the molar mass of the gas? What equation are we going to use? Divided by RT. Woo, that's a big. Woo. RT. So we know, I'm going to move down to the bottom. We know our density is 2.0. We're looking for molar mass. We're going to look for big M. What's our pressure? And it's in ATM, so that's the correct units. R is 0.0821. And temperature is 300. There you go. So now you got to solve for M. Some people like to rearrange the equation before they put their numbers in. So you'd multiply by dRT, so you have dRT, and then you're going to divide by pressure. So some people would rewrite the equation this way and then plug their numbers in. Some people like to plug their numbers in and then solve for M. Whatever works for you is fine. But you have to be able to do a little algebra and solve for M. Yep, your M, you should get 32.84. That's grams per mole. Did everyone get 32.84? You're going to take 2 and multiply it by the bottom there. Then you'll divide by 1.5. The last one, looking at what's the density of argon at a pressure of 551 torr and a temperature of 25 degrees Celsius. So if we're looking at our density equation, we're looking for density, so we can just leave it as D. We're looking for D. Wow. What's our pressure? What is it? No, it's right here. Right, we need to change it to ATM, right? That's what we're getting at. So we have our equivalent is 1 ATM is equal to 760 torr. Because 1 ATM is equal to, 1 torr is equal to 1 millimeter mercury. And if 1 ATM is 760 millimeters mercury, 1 ATM is 760 torr. So we're going to have to convert this. So we have 551 torr. We'll have 760 torr on the bottom and 1 ATM. 0.725. So that's the pressure we need to use, 0.725. Argon's molar mass, 39.95. Just look at the periodic table for that one. R is 0.0821. What's our temp? 298. .18 grams per liter. Good. And the last thing, Graham's law of effusion. This is looking, well, what is effusion? Oh, effusion, it'll be about the same anyways. Effusion is gases escaping through tiny openings. Diffusion is gases just spreading, and they're both based on the rate of the gases, like the speed and the molar mass. So heavier molecules would move faster or slower, do you think? Slower. So they're inversely related. If you have the molar mass is high, the rate is going to be low. The speed is going to be low. If the molar mass is low, the rate is going to be high. So that's why if you look at this equation here, the R1 and M1 are opposite each other. But it's all based, so the R1 over R2 is equal to the square root of M2 over M1. Oops. Yeah. It's also related to the density. They have, you could put D2 over D1 there if you wanted to. depending on what information they give you. But they're opposite, they're inversely related, so they're opposite each other in those quotients. Let's do at least one example here. Compare the rates of effusion of hydrogen and oxygen at the same temperature and pressure. So if we put, which one should be faster? Hydrogen, because it's smaller. So let's put RH over RO, and actually it's O2 and H2, right, as gases. What's the molar mass? We want the molar mass of oxygen on top. Since it's O2, it's 16 times 2. And then this would be 2.02. Do you get 8? 32 divided by 2 is, yeah, take the square root of it. Yeah. 3 point, yeah. What is it? So what this is saying, since we don't know, we aren't looking for exact rates on this one because we don't know the rate of the other. This is going to say that hydrogen is 3.98 times faster than oxygen. So it's like a 3.98 to 1 ratio. Hydrogen is 3.98 times faster than oxygen. So if we, on this one, if we know that hydrogen is 9 times faster, we're going to make the rate 9 to 1, since hydrogen is faster 9 to 1. And since the rate of hydrogen is on top here, its molar mass needs to go on the bottom. And we're looking for the molar mass of the unknown gas. Now this one, how would we solve this equation? Yep, square each side first, so you're going to have 81 is equal to x over 2.02. So now x would be 163.62. So that would be our estimated molar mass for the unknown gas. Okay. So these problems we do at the end of the period tomorrow. So after the quiz, you can work on these. I need to copy it from here. Okay, end of the period tomorrow. Yes. 279 through 282. And then 310 and 317. Okay. That at the end of the period tomorrow. So after your quiz, you'll probably have 10 or 15 minutes, I would think, to work on it.